Okay, so this time we are going to apply the definitions of the different connectives such as negation, conjunction, disjunction, conditional, and biconditional. Okay, so it is very important for you to master the definitions of these different connectives so we can find the truth values of expression under in propositions or a compound proposition. Okay, so in order for us to determine the truth values of any compound propositions for that matter, we have to make use of the truth tables. So in the truth tables, we present all the possibilities of having the truth value of each of the expressions in a given compound proposition. But take note that if we have compound propositions, or if we say compound propositions, we are referring to propositions which are combined or propositions that are combined together and connected by logical connectives such as negation, conjunction, disjunction, conditional, and biconditional. That's why it is very necessary for you to master the differences among those connectives so you can easily determine the truth value of each expression in a given compound proposition. That's very important. Okay, so before we construct our truth tables for these compound propositions, we have to determine first how many rows should be provided in a given table given a number of propositions or a number of variables. Okay, for example, a certain proposition P can be answered only by either true or false. Take note that if there is only one proposition, then we can have two possible options. Okay? So that for every proposition, we have only two possible options. So we have two, and there is only one proposition or there is only one variable. And 2 raised to 1 is equal to 2. That is the mathematical equivalent or mathematical way of finding the possible number of rows when we want to construct a truth table of compound propositions, especially when there is more than two propositions involved in that given compound proposition. Okay, so if there is only one proposition, then we have only two rows, the true and the false only. Take note, okay, one proposition can only be answered by true or false. There are two options in answering our single proposition, so that if there are two propositions, then we have four possible rows, or there must exactly four rows in that given expression in the table of the truth table of that expression. Okay, so that if we have three, if there are three propositions, then we have 8. If there are 4, we have 16. If there are 5, we have 32. So that if we have n, okay, if we have n proposition, then we have 2 raised to n number of rows to be included in the truth table. Okay, is it clear? So we have to look into the number of variables in the proposition so that we can determine how many rows to be provided in that truth table. Okay, let us start. In the first example, we have here our P, okay, P or not Q implies P and Q. Okay, so let us look into the details of the compound proposition. Now, we have our P and the negation of Q. In the first expression, P or not Q. And then the other one is P and Q, our second expression. Okay, so since there are two variables here, then we expect for 4 rows that will be included in the given truth table of this compound proposition. So the arrangement would be, we have P and we have Q, and of course we have our not Q here because we need that in determining the truth value of this first expression, okay? And after that, we have the first expression, which is or not Q. And the other one is P and Q. And eventually, we have our final compound proposition, which is P or not Q implies P and not Q. Okay, so these are the segmented, okay, or the different parts of this compound proposition in which we can have their truth values as we assign the values of P, Q, and not Q. Okay, so first is we have to determine the truth values of our P here, okay, of our P, in which there must be 4 rows. We have true, true, false, and false. And the Q, proposition Q should be answered by true or false alternately. So we have true, false, true, and false. So that the negation of Q is focused here. Okay, so we take only the negation of Q. The negation of true is false. The negation of false is true. The negation of true is false. And the negation of false is true. So that in the first expression here, we combine P and not Q. So we have P and not Q here. Okay? So P or Q. What is the condition under disjunction? The disjunction of two propositions is false when both the truth values of P and not Q are false. So we have here false or false is false. Okay? And true or false is true. And then true or true is true. And then false or true is true. Okay? So this is our truth value of the first expression, P or not Q. Okay, so now we have our second expression, which is P and Q. Take note that in the conjunction of two propositions P and Q is true when both propositions P and Q are true. So take note of that. The conjunction of propositions P and Q is true when both P and Q are true. So let us look at the given values of these variables P and Q. So we have P and Q. P and Q here is true. Okay, so that's the only one that we have a true statement for P and Q. Otherwise, we have false. So false and true is false, false and false is false. Okay, so that is the possible values for the expression P and Q. And the other one is the final compound composition or proposition, which is P or not Q implies P and Q. So that is the combination of the first here and the second proposition. So they are combined through implication, that is conditional, the if and then. Okay, if P or not Q, then P and Q. Okay, so we take the first here and the second. That's why it is very important that we have to arrange the parts of this compound proposition so we can easily determine the values of the compound proposition in the end. Okay, so in the implication, the conditional statement of two propositions is false when the first proposition is true and the second proposition is false, otherwise true. So let us look at this. There is only one statement that could give us false as the true value, which is the second row. So true implies false is false. True implies true is true. False implies false is true. And true implies false is also false. That's the other one. So that the final value, final truth value of our compound proposition P or not Q implies P and Q would be true, false, true, and false. Okay, so did you get it? So first, you have to look into the parts of this compound proposition and then break it down into part by part so that you can easily determine the values of all the parts in the given compound proposition. Okay. The other one is number 2. We have not P or Q implies Q and P. Okay, the second one would be the negation of P or Q implies Q and P. Okay, so we have two variables and we expect for 4 columns or 4 rows rather. So we have P and we have Q. Okay, so in the first expression, we have the negation of P or Q. So first, we have to determine the value of P or Q so we can negate the value of that disjunction, P or Q. And next would be the value of Q on and P so that we have in the final the negation of P or Q implies Q and P. Okay, so those are the different parts in that given compound proposition. We have shown it step by step so that you can understand it thoroughly. Okay, so assigning our truth values for P, we have T, false, or F, and F. In our Q, we have true, false, true, and false. And for our P or Q, again, for the disjunction of two propositions P or Q, okay, the disjunction of propositions P or Q is false when both the propositions P or Q are false. Okay, so it can only be false when both P or Q have a truth value of false. So we have here the truth value now of this one, F or F is F. Okay, and the rest are true. There you have it. Okay, so that the negation of the truth values of this would be false. We have false, we have false, and we have true. Ayan. Okay, there you have it. And then next, Q and P. Again, for the conjunction of Q and P, okay, the conjunction of Q and P is true when both of the propositions have the same truth value of true. So again, we have the combination here, okay. Q and P is true only when both propositions Q and P have the same truth value of true. So in the first one, Q and P is true when they have the same truth values. So we have true here. Okay. F and T is false. The rest are already false. Okay. Next, now we are now ready to give the final answer or the final value of the compound proposition, the negation of P or Q implies the conjunction of Q and P. So we are going to combine this expression, okay, under implication. So we have our final answer, which is in the conditional statement, P implies Q is false when the first statement is true and the second statement is false. So this is our first statement and our second statement is there. Okay. And finally, we have false implies true is true. False implies false is true. False implies false is true. And true implies false is false. Okay, so that is our truth values for the compound proposition. Okay, the final answer. We have true, 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 and false. Okay, so our third example as our bonus example, in which this involves three, okay, three distinct variables. We have P, okay, we have P, we have Q, and we have R. So if there are three variables, then we expect for 8 rows. 8 rows. That is 2 raised to 3, okay, is equal to 8 rows. Okay, so there are two possible answers to be given in a single proposition, and since there are three variables, then we expect for 8 rows. Okay, so we have here the variables P. We have also our Q, our R. Shall we say R, or we have PQ, P or Q first. Okay, and then we have R, and eventually we have P or Q or R. Okay, so the arrangement is better. Okay, so first, since there are 8, we expect for 8 rows in which the division of the true or false must be 4 false and 4 true. Okay, so we have true here, true, true, true. That is already 4. And the other one, we have false, we have false, we have false, and we have also false. Under Q, we have 2 true and 2 false alternately. So we have true, true, false, false, true, true, false, and false. So expect, or you must notice that the arrangement or distribution of the true or false as possible values of the variables P and Q are arranged evenly, so that in our P, in our R, I should say in our R, we must have the alternate alternately. Okay, the values of R must be true or false written alternately, one after the other. So we have true, false, true, false, true, false, true, and false. Okay, so we go back to the expression P or Q. Our P or Q. Again, the disjunction of two propositions P or Q is false only when both P or Q have the same truth value as false. Okay, we can only say that a disjunction of P or Q is false when both P and Q are false. So we look into the condition that is false or false is false. False or false is also false. Do we still have other false here? None. Okay, so true or true is true. True or true is true. True or false is true. True or false is also true. false or true is true, false or true is true. Okay, now we are ready to find the truth value of the compound proposition P or Q or R. So we combine this time, okay, this expression or propositions. We have P or Q or R. So again, we have two disjunctions or disjunctions of two propositions, P or Q or R. So since the truth value, okay, of our P or R as expression is already given, and our R has already its truth values here, then we can have the final compound proposition, which is P or Q or R. Okay, so we have disjunction again. False, false is false. False, false is false. So we have here false, false is false. False, false is false. Okay, so none. The other remaining are already true. So we have true, 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 and true. So that the truth value of the compound proposition P or Q or R has these values. Okay, so that's how we arrange our truth table when there are three variables involved in that given compound proposition. Okay, thank you very much, and if you like it, please subscribe and share also to others. Thank you.